Let's look at another example of using machine learning in industry to simplify a rule-based system. This is based on a project that we at Google Cloud Professional Services did with one of our customers. For competitive reasons, the customer doesn't want us to explain the exact use case. So we are situating it in a different industry and changing some of the details. But the core idea is the same. Acme Widgets, this is a made-up name, of course. Acme Widgets makes sophisticated smoke alarm systems for home use. Again, made-up industry. So they make sophisticated smoke alarm systems. And when a homeowner buys an alarm system, Acme sends an installer to install the system. The installer needs to disconnect any existing system and they need to install the new system. Now, there are many manufacturers of smoke alarm systems, so the installer needs to recognize how the old system was wired and then interface to the new system. The system measures smoke and also makes phone calls. And so we also need to recognize whether they can use the existing phone line or whether they also have to install a satellite connection. So all this is quite complicated. And Acme has a manual that their installers follow. It has hundreds of pages and thousands of schematic diagrams. People make mistakes. They look at the wrong page, they miss a step in the directions, they install things the wrong way. Can Acme do things better? What if the installer goes to the home and photographs the current system? A machine learning model identifies the current setup, the manufacturer, the model, the wiring, brings up the steps, shows the installer the screen, but also reads the steps one by one so the installer doesn't have to climb down from the ladder to go read the book. The installer can ask the assistant to repeat the instruction and then move on to the next step. How do you train such a machine learning model? Photograph all the test units. You see, in order to write the manual, the company already had test units. They simply got a team to photograph these units and train the model to identify them. One problem though, the test units are in pristine condition. They're clean. In the home, there will be dust and cobwebs all over the units. So we don't want to take professional photographs with perfect lighting. We want to take photographs with a mobile phone camera, the kind of way that the installer will take it. We want to photograph the units as they will be when they're mounted, not on a table. We want to simulate the presence of dust and cobwebs. We want to photograph the units from different angles. So just like these pictures of flowers, not all photographs will be taken under the same conditions. So what was hard about this project? Collecting the data. Collecting the data was hard. Training the model was easy. Does that sound familiar?